Started. So again, thank you for everybody for showing up today. I'm Sean Law. I work here at TD Ameritrade. This is Ben Zeitlin from Continuum. You can always reach out to us, right? Or to the PyData Ann Arbor group, either through Twitter or through the email if you want to reach either of us. Again, I'd like to acknowledge several groups. So obviously, NumFocus for sponsoring the Meetup group itself, TD Ameritrade for the venue, Ann Arbor Spark for a lot of the sort of advertising around town, and also a huge thank you goes out to Midas at the University of Michigan for sponsoring the food, so the delicious food that we get here. For the people who are new to this Meetup group, just a couple important points. Emergency exits. There's an exit right down here, the stairs here, and stairs to the right of the entrance right over here. As always, we're soliciting for speakers. So if you work for a company or at the university and you have some interesting data successes or data failures, please reach out and tell us that you'd like to give a talk. Eventually, I think Ben and I would like to host some sort of like lightning session. So maybe have shorter, like 5-10 minute talks. So look out for that, or just email us if you think you're interested, and we'll add you to a list. And always, we're looking for sponsors in the future. And also, please provide feedback to either Ben or I through the Meetup group, through Twitter, through email. And also check out our, GitHub page. So all the talks are added to our GitHub repo. So all the slides, so we'll ask Daniel to hopefully contribute to that. And also we have a website that Brenton's going to bring up. Also, unless you have like quick questions, try to hold the longer questions until the end, although Daniel has really liked sort of a casual interactive session. And also remember that this is a borrowed space, so please do clean up after yourself. So plates, garbage, really appreciate it. As always, I'd like to read the PyData Code of Conduct, again, mostly for people who are new and maybe existing. So PyData is dedicated to providing a harassment-free meeting experience for everyone, regardless of gender, sexual orientation, gender identity and expression, disability, physical appearance, body size, race, or religion. We do not tolerate harassment of meeting participants in any form. All communication should be appropriate for a professional audience, including people of many different backgrounds. Sexual language and imagery is not appropriate for any of our Meetup events. Basically, be kind to others. Do not insult or put down other attendees. Behave professionally. And remember that harassment and sexist, racist, or exclusionary jokes are not appropriate for PyData. Attendees violating these rules may be asked to leave the Meetup at the sole discretion of the Meetup organizers. But really, I'm sure everybody will be kind here, right? So thank you all for making this a welcoming and friendly environment. And as we always like to have is a quick and dirty icebreaker. So simply, we really want to build community, and we want people to at least leave here having met somebody. So everybody think of your favorite season of the year. Favorite season. Turn to one of the people sitting next to you and tell them your favorite season and why it is your favorite season. And don't forget to introduce yourself. Go.
Second season of Friends.
Okay. I like how you interpret it. My season is winter. Because in winter, it hurts. And in the summer, it's comfortable. I'd rather be hurting. And I can control it.
I've always had the idea that it's easier for me to get warm than it is for me to get cold.
Yeah. Yeah. You can put on more clothes. All right. We're back.
Stop needing.
Hello. All right, great. So, hello. Thank you. So another thing that we like to do is hopefully people will contribute in the future, but we like to sort of point out, so this month in data science, there's some quirky, funky things that we've observed, but maybe you want to point them out.
Yeah, this audio set, I think came into my feed. I think it's like a month or two old, but Google has annotated, I think, like over 2 million videos on YouTube with over 500 labels. So you can get a label for what a boat sounds like on a lake, or a boat on a pond, or a boat in the ocean. It's sort of incredible if you ever want to play with that. And this other thing that came up recently is this large self-annotated corpus for sarcasm. It's known as SARC. This is labeled data that's based off of Reddit, which is a lot of fun to just sort of sift through in the /s channel if any people are Reddit fans.
Like if anybody's ever done NLP, that's probably like the single hardest problem is handling sarcasm.
Sarcasm is really challenging to teach a computer to understand. But it seems like all of us seem to understand it intuitively, right?
Hopefully. I see what you did there.
And then PyCon was last weekend. Some of us had the opportunity to go. Marcus and I both did, and Daniel did. Was anybody else there? Okay. Me in the back. Okay. Sorry that we didn't see. PyCon is a great conference. It's the general conference for the Python language. It's incredibly welcoming. It's fairly diverse. There's both web talks, data talks, networking talks. There's talks about the language itself. It's a fantastic place to be. If you ever have the opportunity to go, you should definitely do it. And people should submit. It's a lot of fun, actually, not just to attend, but to also present or give tutorials or give lightning talks.
And next year is going to be in Cleveland, Ohio.
Yeah, next year it's in Cleveland.
So really close to us. The next 2 years.
Next 2 years.
All of the videos for PyCon are already up. So this is a link, the YouTube link to all of those.
Yeah.
And then, again, a big shout out to O'Reilly. So they've offered to give us some free ebooks, so you get to download one of these. But we've added a condition, which is tweet at us. If you tweet the PyData Ann Arbor handle, we will send you the information that you need to grab one of these free ebooks here. So data science related.
Right.
So please do tweet at us or follow us. Another note too, TD Ameritrade. So my team, we're actually hiring. So we're looking for a senior data scientist or senior software developer. If you want to chat about it, feel free to grab me after this, or again to shoot me an email or whatnot. Logan?
We're also looking for a Hadoop administrator too. So also TD Ameritrade.
Maybe a Pachyderm administrator in a few years.
I think that's a new cool thing.
Yeah.
Is there any other announcements from anybody that's looking to hire? Feel free to put your hand up so that we have our... Okay. And then, just an advertisement for our next event. So we usually try to do these at the second week at the beginning of every month, but this is maybe a one-off. So the next one is with Jennifer Marsman from Microsoft, and she's going to be talking about Intro to Azure Machine Learning, and she's going to be using that the infamous or now famous Kaggle Titanic data set. And this is on Thursday, June 8th. Same time, same place, but it's going to be 2 weeks from now. So please sign up. And then with that, I guess just the website.
Oh yeah, so I didn't like the Meetup page because you have to join the Meetup in order to get access to it, and sometimes I'm on my phone and I don't. Anyway, so I started building a GitHub page. So if you want to go to PyData.arbor.github.io, I'll start posting everything over there with all of the information, so you don't have to go to Meetup to download a talk or communicate.
Yeah,
an alternative.
Yeah, and the videos are recorded, and once they get uploaded to the PyData channel, then
we'll post them there.
We'll link them there as well, so you can grab them from there. So I'll flip over.
So with that, I'd like to introduce Daniel Whitenack. He's from a company called Pachyderm that's based in San Francisco, although you are remote in Indiana.
Correct.
Maybe Pachyderm is hiring?
We potentially are. We're definitely looking for contributors.
Okay. So Pachyderm is an open source data management, data science product, data pipelining, and I look forward to hearing more. So please welcome Daniel.
All right. Great. Well, thank you for, let's see, I'm going to move this maybe so I can walk around. Awesome. How you guys doing? Great. Awesome. Okay. So I'm Daniel Whitenack. I work at Pachyderm, like was mentioned. I'll talk a little bit more about Pachyderm later in the talk. But excited to be here. Excited to this is my first time in Ann Arbor, even though I live reasonably close. So excited to be here and talk to you guys. So today I'm going to talk a little bit about machine learning workflows and machine learning pipelines, and some of the kind of struggles and challenges that go along with that, and then how we can, at least some ways of overcoming those challenges. We'll start out by just kind of presenting some of those challenges. Then I'm going to jump right into a demo of an example machine learning pipeline, because I know all of you guys are technical people. You're programmers or engineers or data scientists, so you won't really believe me if I don't show you anything. Plus, it's a lot more fun. So we're just going to kind of jump right into that. And then at the end, I'll give you some resources. And as was mentioned, these slides will be up. So there'll be a few links at the end. Don't feel like you have to grab a picture. We'll post those online, and you can follow the exact links. Sound good? All right, perfect. So just to get an idea, how many data scientists are in the room? Okay, impressive. How many data engineers? How many just Python programmers? Okay, everybody. All right, cool, awesome. So as most of you know, I think a lot of this room are probably familiar with some machine learning type of problems, workflows, and maybe you're implementing those in your own organization. But there's a few different challenges that come along with those sorts of workflows that I think are pretty consistent throughout industry. So the first one of those I would say is reproducibility. So some of you guys might be familiar with this sort of thing that's going on. This was basically how my grad work in academia ended up. After year 4, my file names were getting increasingly long to generate figures good this time with that other config that I had yesterday, .py or something like that. So there's this real problem of in a data science workflow or in a machine learning workflow, you necessarily have a bunch of different things you're doing. So you're cleaning data, you have a bunch of different data sets, you maybe have a bunch of different plots, you have a bunch of different scripts. There's a lot of different pieces to the puzzle. So actually tracking and figuring out how those are supposed to fit together and actually being able to reproduce that is a really hard problem. So why should we care about reproducibility? Anyone have an idea? Shout it out.
Collaboration.
Yeah, so collaboration is a great first point. So none of us work on silos, so you might have heard this term data science unicorn or something like that. This does not exist in this world. So there is no person in this room or elsewhere who has all knowledge about all algorithms and techniques that you need to solve every single business problem. And we all work on these teams. We all have various sets of knowledge, so we need to be able to collaborate well to be able to both review and critique each other's work, but also incrementally improve on it, right? We want to be a functional team. And if I give you something and you're not able to even reproduce what I've done, it's very unlikely that you're going to be able to improve on it or add to it, right? What else? So, one at a time. Yeah, here.
Validation of results.
Validation of results. Was it validation of results? Another one here?
Time.
Time?
Save time.
Save time? Okay, yeah. So, I would say, the time saving and maybe even the validation comes back to some points around, even my own personal workflow. Even setting the collaboration thing aside, if I'm not able to understand what I did yesterday and I'm really forgetful, so I've already forgotten what I did yesterday, if I'm not able to come back to that, I'm going to have a very inefficient workflow if I'm not able to reproduce the exact things that I've been doing. And also validate those on a team. So this might kind of lead into a third point, which I like to say is compliance. And we all are going to have to deal with this pretty soon if you're not dealing with it now. I don't know if you guys are aware, but there's a bunch of regulations being passed specifically in the EU, the GDPR and other things that basically says that users are entitled to an explanation for algorithmic decisions that we make using their data, which should for everyone in this room just like absolutely terrify you. But I mean, when it comes down to it, if we're not able to actually reproduce things that we've done or validate things that we've done, know what data we process, then we have no chance of being compliant with those things, much less validating things internally. So I think those are all great points. I also think that, you know, managing our workflows is a little bit of an issue right now in data science and machine learning. We've kind of got into this scenario where I'm able to produce this really cool, sophisticated stuff on my laptop using these tools and frameworks that I like, but it's really difficult for me at some points to actually fit that into a company's infrastructure, right? If it just stays on our laptops, then it doesn't produce value. But then, like, we've got this rest of our engineering organization that isn't familiar with all of these tools and frameworks that we're using. And there's cool data engineering people who are writing these really wicked fast pipelines, and our stuff just really doesn't fit into that framework. And so, like, a lot of times there's this friction between those organizations. And moreover, if there's that friction there and I'm not able to deploy my stuff, if I'm not able to successfully put it into infrastructure, then it's not going to produce value for a company, right? Which produces friction with the business, right? Because they're paying me money to produce value, right? So this is a picture from Josh Wills, who's, I think he's still head of data platform at Slack. And then kind of last, it's maybe related to reproducibility, but I kind of think about it a little bit differently. Reproducibility, you know, has to do with, you know, maybe a single stage or a single analysis and reproducing what you've done before or validating what you've done before. But we all know that the workflows that we're doing are not single stage workflows, right? So we've got this that produces that and this that produces that. We've got a training set that builds a model, and the model makes an inference, and then we make some plots. And so there's this other idea that I like to call provenance, or like audit trails, which also is very related to debugging and maintenance, because at a certain point, like as we're deploying all of these pieces, it becomes increasingly hard for us to say that this piece of data or this result came from this specific model, which was trained with this specific data, which came from this specific data source, right? And things like that. Okay, any questions, comments about that before I go on? Maybe you disagree, agree, Snyder mark? No? All right, cool. So I haven't offended anybody yet. So that's all the, yammering that I wanted to do. So now we'll actually get into some fun stuff. So what I'm going to show today is not like the most groundbreaking of machine learning algorithms or anything, or the next big deep learning model. But what I'm kind of intending to show today is that even in the most simple of machine learning workflows, that we could like distill the machine learning workflow down. And for the most simple of those workflows, that workflow already exhibits these challenges. And it especially exhibits these challenges as we try to push it and scale it to production. Right? So, okay, so the scenario that we have is we're all working part of this, you know, really innovative startup. It's turns out to be a gardening startup, and we know that our users are gardeners, and gardeners really love to do one thing, and that's like measure their flowers. Okay, so they like to measure the petals of their flowers and all this stuff, and moreover, they don't really know like which species of flowers they have. So a really interesting problem that we could solve for them is if we could take those measurements they're making of the flowers and predict what species of flowers they correspond to. Okay, so like all of you guys are familiar with this problem likely. There's this data set. If you haven't seen it, it basically tells us a bunch of measurements of flowers. So like different pieces of the flowers, and then a corresponding flower species, actually just like an iris flower species. So what we're wanting to do is we're wanting to take this data set and train a model that will be able to predict the species of these flowers. And then as new measurements come in, we're going to want to utilize that model to make predictions of the species. Sound reasonable? Okay, cool. So I'm the first one to take the crack at this and on our team. And what I say is that I'm going to create a Python script that takes in this data set and it trains a model. And then I'm going to output from that script a persistent version of that model, in this case, a pickle file, and maybe a little bit of metadata about the model that I trained. Okay? And I might want to do this because I don't want to train the model every single time new measurements come in. I want to have a persisted model that I can utilize when I need to use it. Okay? So then I'm going to have another Python script that takes in that model as input, and then it takes in various other sets of attributes. And for each of those sets of attributes predicts a species of flower. So this is my workflow. Seem okay? All right. So I've kind of developed this workflow. It seems like okay to me. It makes sense, right? And it might make sense to you guys, but really, it already exhibits some issues that we need to deal with. So first of all, we've got a bunch of different pieces here, right? And I have this picture in my mind, right? But when I give it to someone to code review or I give it to someone to work on, really what they see is this, right? They see a bunch of Python scripts, they see a bunch of files, I'm referencing this, I'm referencing that. And so really it's not so obvious what goes into what and what I intended. Now obviously documentation can help a lot here, but like this is a really simple problem. As the problem gets more and more complicated, it becomes increasingly hard for me to convey in a really effective way what I'm doing and the workflow that I'm intending. Okay. Also, I mean, regarding like the workflow management issue, I've kind of just like created a couple of single-threaded Python scripts here, right? And like we want our gardening startup to be wildly successful, right? So it's unlikely that I'll be able to just like run these Python scripts as is on like production scale data, right? So I've created something on my laptop that I kind of like, but I'm now running into this workflow issue of something's going to have to change before I put it into production. And actually, that also brings in, it kind of feeds the cycle, because most of the time when I'm thinking about scaling things up, I'm also thinking about doing what? I'm thinking about adding more complication into my code, right? So maybe I pull in something like Dask, or maybe I pull in something like Spark or something like that. Regardless, I'm adding complication to my code, and that necessarily makes it harder to maintain reproducibility. So as an example, I mean, we're all like amazing Python programmers here in the room. How many lines of code do you think the average Python programmer can write before they introduce a bug into their code? 2, 3, 0. So you guys are really like the glass half empty crowd over here in Ann Arbor. So it turns out to be about 20 lines of code or so. So like for every 100 lines of code, we're introducing 5 bugs. I think if I did that math right. So the point I'm trying to make is that like we developed this simple workflow here. As we think about scaling, as we think about dealing with different issues in production, if we're thinking about making our code more complicated, then we have to realize that that's going to introduce more issues around reproducibility. So even if I was able to reproduce my workflow here, I might have trouble as I kind of try to scale that up. So my proposal, what I think would be cool, is if we could take these same single-threaded Python scripts that are nice and simple and that we like and run on our laptop, and run them the same way with the same behavior on a production cluster in a production pipeline that also tracks all of our provenance and allows us to reproduce every single thing that we every single result that we produce enables us to reproduce that. So that's kind of like what I'm going to show now. With the goals really being to maintain like the simplicity here, which also helps us maintain reproducibility. It helps us deal with the time issue of us like having to rewrite things and manage more complicated code. And it also helps us in our tracking, in debugging, and maintenance. So this is where I'm going to talk about this open source framework that I work on called Pachyderm. And this is really like what we're going after with this framework. So Pachyderm is a completely open source project. So I'll give the links at the end, but you guys can go. There's a nice beginner's tutorial. You can download it all. You can run it all. You can spin up everything, without paying. Everything's open. And it really has two pieces. So there's this data pipelining piece, and there's a data versioning piece. So I think it will probably be easier if I explain it in the context of our problem here. So this is what that workflow would look like in Pachyderm. So you can notice that I've basically got the same structure here, right? And I've actually got the same types of files. But now in Pachyderm, each one of these cylinders, each place I have data in this data pipeline, I'm going to version that data. So I'm going to put that data under version control. Think of like Git for data. So each one of these, like if I look at my training data, I can make a number of commits into that training data set. And all of those changes of how I change my training data are tracked over time. And I can look back in history at any point in time throughout history and see exactly what my training set was. Similar for my model. Each time I train a model, that goes into another repository of data that's versioned. And at any point in time, I can go back and see what was the version of my model at this point in time. And that goes for each place here. Then in between the points connecting these, the place where I'm actually doing processing, you can see that I'm going to run those same scripts that I had before. I'm just going to run them inside of a software container, inside of a Docker container. So these are just Docker containers that have my same Python script in it, which means that, especially if I test and build the Docker container locally, it's going to behave the same way in this pipeline as it did on my laptop. So that also helps with reproducibility, but it also allows us to do some interesting things with scaling, which I'll talk about in a little bit. So that's kind of like the processing and the versioning piece. I guess I should also say like the processing piece, since we're working with containers, this could be Python, right? But it could just as well be Julia or R or whatever language, TensorFlow, Spark, whatever you want to run. And then like, because we have this versioning plus the pipelining, now we get something really interesting coming up around provenance and tracking. Because now that I have all of these pieces connected in a pipeline, and I'm versioning all of the pieces of data, I can say that this exact inference came from this exact version of my model, which was trained by this exact data set. And every time I update my code, every time I update my data, I have a tracked record of that, such that I know exactly what data produced what data and what containers were processing that data to produce the specific pieces of data. So I created something that provides exact reproducibility and this idea of provenance, or like an audit trail, tracking what went into where and produced what. Does that kind of make sense? Threw a lot at you there. So, your questions? Yeah. No, so the question was around if I have all these things flowing around and I'm tracking them, let's say I have a specific, and correct me if I'm wrong with the question, but the question is if I have a specific piece of data, is there a way to like very quickly identify all of the different things that contributed to that data? Is that the basic question?
It's in essence, it's trying to find out whether you can get the whole state in a simple bookmark that says, here's all the states
Sure.
that resulted in this.
Yeah, so now I understand better. Yeah, so the idea is like, for instance, I have a specific result. Let me get a snapshot of all of the pieces of my pipeline that created that result. So I'll actually show that a little bit later, but again, we call this kind of provenance, but you can do like an inspect on any piece of data anywhere in this pipeline, and it will give you that exact snapshot of all the other pieces of the data that contributed to that data, along with the specific commit IDs. Similar to like, think about Git, like the commit IDs of the data that contributed to that. Yeah. Other questions?
If something's changed, like attributes right there, can you put a note to why it's changed?
So right now you can't, as far as like so the question was, if I make a change or I make a commit, like in Git, there's the idea of a commit message. So you can say like, I updated this because blah. So right now there's not, although any data that you put in here is versioned. So what we see people doing, like right now, like you can see I basically output some metadata with this model. So you can very easily save just that metadata as another file in this version control. It's a little bit awkward as of now. I mean, I think we get this question a lot, so I think it's in the feature pipeline of what we're developing. But for right now, the workaround is kind of the metadata. Yeah.
I have a question. Can you control when you want to run models? Because if I have like huge data sets in the order of terabytes, and if I keep on adding my training data, and if I train against my models, my cost will increase exponentially every day or like every week. So can I have like hooks to say, do not run the model, I just want the data?
Yeah, so the question was like, if you could control when the model is run, like instead of every time you update the data set, maybe run it only after a certain period of time or only on certain commits. So there's definitely that functionality. By default, we will keep this whole thing in sync whenever you update anything, but that's all configurable as well. You can do things like pause pipelines and then restart them when you want, or like run jobs one-off, or like just supply certain portions of a repo, like a training data set to a model. So all of those things are possible. Yeah. Cool. Yeah.
Just curious, have you thought about actually applying learning to the flow of models as you go through, so you could actually optimize and
Yeah, so the question was if we've thought about kind of applying learning as things were coming through here. So and maybe like optimize like what model is trained. So we've definitely thought about that. I think one important distinction here to make is that we kind of provide this framework of pipelining and this versioning capability. But the code that's run here is exactly your code. So I'll show you in a minute, like that code running there is the same thing I could run on my laptop, which means that you can run any sort of logic, any sort of code you want in this pipeline. For example, like you could do a completely distributed hyperparameter search and then automate in like a reduced step after that. You could automate like the selection of optimal parameters or something like that in the output. So really it's up to you what you run in those stages. We don't like make opinions, I guess, about how about the processing that you should run, just that it runs in containers and it inputs and outputs version data. Yeah.
In your diagram, is each script running in a separate container?
Yeah, so here each of these scripts is running separately, and that's intentional. So the question was if both of these are running in a separate container. So there's kind of a dual answer here. So similar to like if it was on my laptop, I would have these two scripts because I don't always want to retrain my model. So these would definitely be two different workers or two different containers running. But for example, if you wanted to have a single Docker image with all of your scripts in it, you could run that same Docker image and just execute a different command in each of these stages. Yeah.
Can you control the number of nodes per pipeline process at every stage?
Yes, you can. So the question was, can you control the number of workers per stage of the pipeline? So yes, and I'll show that in a little bit. So each stage is individually scalable. Yeah. Cool. other questions before we jump in? Yeah.
Just a little note. If you are doing some training, you also, for reproducibility, you have to basically keep track of all the seeds for random number generators.
Yes.
So it will be part of your model persistence.
Yes, so that's a great point. So the comment was that in addition to, like, if you have some type of non-deterministic step or randomness that's part of your model, you also need to be tracking the seeds that you're using for exact reproducibility. So there's two kind of answers here. The first is, like, that's totally possible here, and this is, again, we can version any data here. So if you want to version your seed here, or even have multiple different seeds that you're working off of, that's totally fine. The second point, which I think is more general, is I tend to sometimes get, like, a little bit of pushback when I talk about reproducibility in terms of, like, people say, you know, well, like, I'm using a model that's not always going to produce the same number on the output, right? Because it's non-deterministic or whatever. So I totally agree, and those models are useful. But I think we can't get away that easily with saying that we can't maintain reproducibility there. At the very least, I would suggest, like, in those scenarios, you can run that model over and over again, right? And you should be able to have a predictable distribution of results for that model. And so, like, whatever model you're using, whether it's going to produce the same number or class or output every single time or not, we as data scientists have a responsibility to understand what is the expected behavior of this model, because, you know, the things that we're producing have a pretty big impact at this point. I mean, we're producing applications that we're expecting people to make decisions based on. If we don't know the expected behavior and stuff kind of goes south, and we can't explain what's going on, then guess what? Those people will never, ever trust your model again. Like, even if you fix it, they're never going to pay attention to it again. So that's, like, the first point. And the second point is, like, I mean, the stuff we're producing now is pretty, the impact that it's having for users is more and more, right? So, like, if my self-driving car turns left instead of right, that has some pretty serious impact, right, on a user potentially. So, yeah, exactly. So we, I mean, I guess what I'm saying is, this was kind of like a total aside, but we need to have empathy for our users and for the people that are consuming our model, and we need to have, like, an understanding of what we reproduce. So in this case, it might be that you version that seed so you can exactly reproduce things. It might be that you just you run an experiment over and so you can run this over and over and then save the version results and look at that distribution of results to get your expected distribution. Yeah. Cool. So I went way off on a tangent there. You guys ready for a demo?
Yeah.
All right. Yeah. Cool. So we'll move over here. So I'm just going to set up. I'm going to set up this, and then we're going to kind of see how all of those things play together. And what I have here is a cluster set up. If you guys are familiar with Kubernetes, this is a Kubernetes cluster. If you're not familiar, don't really worry about it. Kubernetes is a way to manage deployments of containers on a multi-node cluster. And that's basically what we're doing here, because remember, all of our processing stages are containers. But as far as Kubernetes, you don't have to worry too much because you'll be interacting with Pachyderm. So Pachyderm is running on this cluster. This is just like the Pachyderm daemon or the service that we're going to be interacting with. So as I'm interacting with Pachyderm, all I'm doing is sending requests off to the service, and then it's doing the corresponding things. Okay. And the way that I'm going to interact with that is with pack control, our command line tool. So there's also various ways to do this. So there's a Python client, for example, that you can use. There's a Go client. We work off of protobuf, so there could be any client you want. And there's a UI kind of in the works as well. But I'll just be using the command line here. I was just listening to a podcast on the way over here about like the pronunciation of commands like this. I guess there's also cube control, which I call cube control, but I guess also people call kubectl and kubectl. So I don't know. I'm going to call this pat control. Sorry if that goes against your pronunciation. But I have so I have Pachyderm here, and one thing I can say is what repositories of data version data do I have in my cluster? So right now I don't have any. So remember, each of these kind of pieces is a version set of data that we call a repository. So what we need to do to set up this pipeline to begin with is to create these two input repos here on the left-hand side. This is kind of what's going to drive the rest of our pipeline. Okay. So first I'm going to create a repo called training, and then I'm going to create a repo called attributes. And as you might expect, now I have two repos of data, or two collections of version data that don't have any data in them yet.
Excuse me.
Yeah.
When you say repo, what are you actually creating?
So right here, all that's been created is an entry in our internal metadata store that says we have a repo called attributes and we have a repo called training. So that's the only data that's stored. So all of these versioning semantics are driven by a metadata store, which we use etcd. It's very, very scalable. But yeah, that's basically what we're doing here. And that's also what will track like the commit IDs and what jobs have been run and that sort of thing. So
empty folders.
Yeah, so basically this is just saying I have an empty folder. I have an empty collection of data. Yeah. So now let's actually put some data in there. So I have this iris data set, which I'm sure you guys are familiar with. So again, we have these measurements of the flowers and the corresponding species. And all I'm going to do is say put this file into the training repo that I just created on the master branch. So think again, like kind of like Git-like semantics. You can have different branches of your data. And I'm going to put a file that is iris. So now, if I look at my repos, now I have data in this training repo. And if I look at what files I have, I can see that I have iris. So now this data is on the cluster. And this is the version data that my pipeline is going to be interacting with.
What was -c? Was that for create?
So that was for, like, you can also, here I just put one file. You can also open a commit and then make a bunch of changes and then close the commit. So -c just says, do that all at once, because I'm only doing one thing. So open the commit, put the file, close the commit. Yeah. Other questions?
You can recursively do it too, right?
You can, yeah. We'll do that in a second. So actually, here I've just shown, like, you can put a normal file. There's, like, a bunch of different iterations and combinations of this. So you can put files recursively. You can put files from an S3 bucket. You can put files from a URL, so like a web scraper sort of thing. You can put files from a list of files. There's like a bunch of different ways. And of course, you can do it all with the Python client or other ways too if you want.
Are your flags stackable? Could you do -cf?
I don't think so at the moment. That's a great question. I don't think so.
What was the question?
So sorry, the question was if you could combine the flags like -cf instead of two separate flags. But yeah, I don't think so at the moment. All right. So now we have these two version sets of data, and I've put my data into this training repo. Now let's actually do this processing piece. So let's build out this part of our pipeline. So I'll just show you, let's see, I think it's called.
Is that the Pachyderm prompt? That's the arrow?
No, that's just, I just simplified my prompt for demos. So it's really short. Yeah, so here, the question was if that was the Pachyderm prompt, but this is just the normal terminal. So here's the training script that we have. If you notice here, I'm not importing anything special. I'm not saying like import Pachyderm or something. I'm just importing my normal stuff. So this is the same way I would run it on my laptop. I'm taking an input directory, which has my training file, and I'm saying write out the model to an output directory. And then I'm doing my training here, and then exporting some metadata about the model. So here, this is just a script, like a normal script you'd run on your laptop. The only thing that I've done is I've put it in a Docker container. So you could use like the standard Docker container. Here I made it a little bit special just to make it really small, but just adding this same script here. And then to create, so I have the script, I have it in a container to create this part of our pipeline. All we need to do is supply Pachyderm with a JSON file that tells it how to process that in that pipeline. So this might look a little bit complicated, but all it's saying is create a pipeline stage called model. And in that stage, run this Docker container, which I'll actually change before I forget, because I just showed the SVM model. And then when you run that container, run this command in that container. So this gets back to the question earlier. You can definitely have the same container and run different commands. So here I'm just saying run my training script. And the only other thing I'm saying is run it on that training input repo. So I have like the model, how to run it, and what to run it on. Yeah?
Do you have like a 2 or 3 minute explanation of what Docker containers are?
Sure, yeah. So like, how many of you are familiar with like a VM, right, or VirtualBox? So a Docker container, it kind of almost feels like that, but it's not quite the same. So with a VM, you actually have like a guest, you have an OS running inside of the VM, and you also generally have to specify what resources that VM is going to take up. So a Docker container, you can see like with this Docker file here, so with this Docker file, I'm kind of installing a bunch of stuff in this image and then adding my scripts. So it kind of almost feels like I'm working in Ubuntu, but it's actually in the Docker container when it spins up. There's not an actual OS running in there. So all of these containers are sharing the resources of the underlying Linux kernel that they're running on. So when you spin up a Docker container, all Docker containers running on that node will share the same resources of the underlying kernel. And they're also, as a result of not having to have that OS in them, just like a file system and your libraries and dependencies, they're much smaller. So like this Docker container, I think was about like 80 megabytes. If you're looking at like a virtual machine or other things, you're looking at many gigabytes, right? So it makes it a lot more portable as well. Yeah. Yeah.
And just to interject, just even baser level, a Docker container is almost like an onion. It's built on layers. So you say, I want it built off of Ubuntu. I want it to have Python 3. You list out all those dependencies within the Docker container, so that way when somebody uses that container later on, they don't have to worry about tracking down your dependencies. So it furthermore helps reproducibility later on.
Yeah, so if I run this Docker container, like I have Docker running locally, if I run that Docker container locally, and then I run it on a server in AWS that's running Docker, it will literally run the exact same way in both of those environments. There's absolutely no change.
But how does it ensure that it provisions all the same resources?
So remember, it shares the underlying resources. So like if I spin up a service, let's say, and then it's just sitting there lazily, not doing anything, it won't be sucking up resources except what it's taking to spin up that Docker container, which is very, very minimal. And then as I receive load into that, it will utilize the underlying resources of the underlying node.
So if you want to migrate your Docker container from your laptop to an AWS server, how's it going to reconcile the differences between whatever resources may or may not be available on that server, different versions of libraries?
So all of that is in. So the question was, how is it going to reconcile dependencies? So all of that is inside of your container. So like was mentioned, you can say like, run this with an Ubuntu file system and all of these dependencies. And you can say Ubuntu 14.04, 16, whatever, and install those. And it'll just be exactly like it's running on Ubuntu, except underlying its Docker engine that's running on the Linux kernel of the host. So all of that mapping to actual resources is handled by the Docker engine, which is what's running these Docker containers.
Okay, I can't see the difference right now between that and a VM, but I'll go home and read.
Yeah, I would look up if you just search online for like Docker image versus VM. There's a nice picture that shows this. The biggest difference is that there's that lack of actually the full OS running in the container.
Got it.
Yep. Okay. Cool. So yeah, again, so we're saying in this pipeline stage, so we're going to create this pipeline stage model. We're going to use this Docker container and run this command in there, which is literally just the same script that I just showed you. And we're going to run it on that training data. And those other little pieces I'll discuss shortly. So then to create this, I just say create pipeline, and I supply it that JSON file. And now actually something interesting has happened. It's actually went ahead and spun up a job to do that processing. So the reason for that is that Pachyderm said, you have told me, remember this is kind of like declarative. It's like, you have told me that there is a model pipeline stage that's supposed to process training data. And you've committed training data that hasn't been processed yet. So I'm going to go ahead and make happen what you told me to make happen and run this pipeline, train the model, and output the results. Okay, which hopefully is done by now. Okay, success. The other thing that's happened here is now if I look at my repos, I've actually got one more. Okay, so also what Pachyderm did is it said, I'm going to process this data in my pipeline stage, but then I'm also going to output data. So I'm going to create another version collection of data that corresponds to the version data that's output from this pipeline stage. Okay. Yeah.
So it's going to do that for each commit essentially, right? So it's my responsibility to make sure that the data that I put into one commit is self-consistent. Right?
So the question was, since it's doing this for every commit, then you're responsible for ensuring that the data committed in each commit is self-consistent. So yes and no. So there's various ways to configure this. But for example, similar to like if you're feeding data into your application running anywhere, if you supply a wrong format or corrupt data or a lack of data or whatever it is, then the pipeline will fail. Like you can get all those logs and that standard thing will happen. But one nice kind of thing that isn't the same as that case is like you can specify what I'll show here in a second of like how to process data in that version repo. So in this case, we always need all of our training data to make our model, which is a lot of the case with training models. But let's say I was doing edge detection on images. I could put in 1 million images, process all those, output the corresponding output. If I add one more image, I only need to expose that one image to my processing step because all the other ones have already been processed and they're totally independent. So Pachyderm is diff aware. It knows what data is new, so it can just supply that new data to the processing step. And of course, again, this is completely configurable because that wouldn't work so well in this case, right, with the training case. Yeah.
Show how it knows what our model outputs.
Yeah. So that was actually a great question. So the question was, how does it know what is output from the model? So if you look here in this pipeline spec, remember I take in an argument for my input directory and an argument for my output directory. if I was running this locally, this might be like /temp/iris or something. But here, I'm using specific directories. So when the container comes up and it's processing data, Pachyderm will automatically mount that data in the container at /pfs/training. Then correspondingly, whatever you put into /pfs/out, that's what's going to be versioned in the output. So /pfs/out is kind of this magical directory that is like all your output.
So that's a naming convention?
Yeah, so the /pfs is just a convention. But yeah, it's just like working with any other file system. So like you take files in, you write files out. Yeah.
I was a bit confused when I was thinking about like how if you have to split data and like split the same training data into multiple pieces and then run it across over multiple models and get results. How would you?
Yeah, so the question was how exactly this splitting of data will happen. So we'll get to that very soon. So I'll defer your question for a moment, but I'll show you very quickly. Yeah.
So you mentioned Pachyderm being diff-aware, data diff-aware.
Yeah.
You showed the CSV. How does it handle like binary files, like JPEGs? Like compressed?
Yeah. So one distinction here is that we content address and hash your files, but the versioning happens at the file level. So if you really want to diff like lines or JSON blobs, for example, you can totally do that. We have a flag that's just like --split, and it will split that into multiple different pieces of version data. By default, it will just diff on the full file. In the case of like the images, that would mean like if you could commit the same image over and over again, and nothing would change. Like the image wouldn't be copied. Like nothing would change or be triggered. As soon as you commit any change to that image, then like we would track that as a change or an update, but we wouldn't like diff within that file. Yeah. Other questions?
How do you see version history save the data and the model and the training data and the model? Is there a way mechanism to just
to see it?
Like in Git?
Yeah. So the question was, is there a way to show the version history? So I'll get to that in just a moment. Yeah. So I'll also defer that one, but let me know if I don't hit both of those points. Okay. So we have this. We are kind of at a point where we trained our model. That model is there. We can also verify that the files got put there. So there's my model files that I expected. Now let's just create this next bit of the pipeline, and then I'll get into some of those other questions. So the next piece of the pipeline is very similar. So again, I have a simple Python script, basically the same, taking command line arguments for the directories. Here, the only difference is I'm just like, whatever files are in here, I'm just walking over them, and for each of the attribute files, I'm doing an inference, and then outputting the results. Okay. And then I have another corresponding file for this inference stage. Again, just this is my stage. This is what I'm going to run. The main difference here is that I have two inputs. And I'll get back to these globs here in a second, which is related to your question. But here, just think of like I have two inputs, one model, one attributes. That's how I'm going to process the inference. Okay, so let's go ahead and create that pipeline. Okay, but I still will only run one job. So why do I still only have one job? Why didn't I automatically start doing inferences?
No attribute data there.
Yeah, exactly. So I've created this collection of data, right? But what Pachyderm is saying, okay, I know that I'm supposed to run inference. You just haven't given me any data yet to do inference on, right? So it hasn't launched anything. So let's go ahead and do that. I just have a couple of test files here. So these just have different sets of attributes in them. And this time I'm going to put them recursively, as I mentioned before. That's just that extra flag. I'm going to put all those files in there. Now I have data in there. And if I look, I've spun up another job and it's actually already completed. So it now said, now you've given me inference data, now I need to make inferences. And likewise, it's also created an output repo for inference of the same name. If I look at what files are in there, I've got 2 corresponding to each of those files that I put in, and I can get those. Let me get the second one. And there's my species. So we've now created all these version pieces of data. We've set up our entire pipeline such that now anytime we update any of these pieces of data, we're going to automatically trigger an update of everything else. So this is like a pipeline that keeps itself in sync with changes to data or changes to code. But now let's actually dig into these kind of 2 questions that came up, one around scaling and one around the actual provenance that I mentioned. Yeah?
Can you quickly join between attributes?
So like, you mean do like a union of the data or something? Yeah, so you can totally, if you wanted to create like, say another, like a plotting or something, you could totally take the input of both of these and just like process that in another stage. You can just, or if you just want to get the data, you can use like the command line tool like I did, but there's also, like I said, the Python. Like if you wanted to spin up a Jupyter notebook and get both of those pieces and do it interactively, you could use the Python client to pull in both of those pieces real quick. Yeah?
So the Docker containers themselves, are they also versioned?
Yeah, so that's a great question. The question was if the Docker containers themselves were versioned. So yeah, so there's a registry in the cluster that's maintaining those images. Now you can, so it is possible to shoot yourself in the foot here, because if you specify like in that image, like if I specified like latest, that's always going to like overwrite the latest image. So
because I could change those Docker images, I could change the scripts within, right? And so
yep.
like I'm moving the provenance.
Yeah, so you can definitely do that, but it's not best practice. So we actually provide a convenient way, which I'm not going to show here, but I can totally point you to. We have an update feature where if you're updating, like if you're making changes, and you specify a flag, it will automatically tag a unique version of that image that's tracked with your specific processing. So that's the way to do it. Now you can totally like avoid that and use latest, and you'll run into the issue that you just mentioned. So there's still like that best practice there, but the functionality is provided. Yeah. Okay, so let's address like the scaling thing first. So now like let's bring it back home. We're at our gardening startup, and we've got this cool pipeline built, and now we're like really growing, and we've got like tons of these attributes coming in, right? Now remember, this is like my single-threaded Python script, and really I would like to keep it as simple as it is, but now I need to scale up this stage of my data processing. So what I can do actually is go back here and go down to this parallelism spec, okay? And you can see that there's, here I've just set this to a constant of 1. That means it's only going to spin up 1 worker to do that processing. But I could just as well easily change this to 10, right? Oops, 10. And what's going to happen is, this gets back to like how you're splitting the data. So you can see I've kind of specified this glob pattern here. So this is similar to like what you would use on the command line. This is saying that you can, Pachyderm, you can split the data based on everything that's in the root of that repository. So all files that are in the root of that repository. Whereas here, if you look at the model, I just have /, and that means like every time you process, you need all of that data because you need all of that model. So this is how Pachyderm knows which data it can split across. And this is really flexible because you can split across specific directories, a bunch of different directories, a bunch of different files, specific directories within a repo. There's a bunch of different ways to split your data. And you can also, like here I've specified cross, there's different ways you can join your data to cross, union, or just like individual repos. And we can talk about that after too if you're more interested. Yeah.
Given that it's Python, are you actually spinning up separate Python processes for each of these workers?
So it's actually, the question was if I'm spinning up different Python processes. So I'll show you in a second when I update this, but it's actually going to spin up a bunch of different containers. So think about like in like the Hadoop world, the way you do distributed processing is you distribute across these like Java, Scala, Mapper, Reducer classes. That's the unit of data processing. Here, the unit of data processing is a container. So like when you're splitting up your work across this, you're spinning up multiple containers where each one of them is running that same script. Yeah. So.
You don't need a single node for each container then, right?
No.
You need 10 nodes for this.
Yeah, so actually this is, under the hood, this is running on a single node cluster, so you can see I spin up multiple. Now, obviously, like you can only do so much with the nodes that you have. So, you know, generally it doesn't do you much good to spin up like more containers than your number of nodes times your number of cores. But, you know, yeah. Cool. So let's see if I can do this. So I've changed that now. Now if I do pack control update pipeline infer, and then I look at my cluster, it's actually spinning up all of those different workers. And if you don't know anything about Kubernetes, like don't worry about it, but there's actually some cool stuff here. These are being created as replica sets, which means that this cluster is self-healing. So if I lose a node, Kubernetes will automatically reschedule the state of all of my workers across the other nodes in the cluster and kind of self-heal in that way, as well as if I auto-scale my cluster, it will reschedule those resources across the new nodes. So this is actually pretty nice under the hood.
Or you can scale dynamically.
Yeah, so here, like, you can...
Here, in the middle of the process.
Yeah, I mean, you saw that, like, when I... so when I spun up the new workers, it actually terminated the old worker because it didn't know if I wanted the same worker instance or new ones. But if you have a job running and that fails as a result of you doing some scaling, Kubernetes will automatically reschedule that as well. So I did that. The other question was around provenance, so this will be the last thing I'll do. I won't keep you guys any longer. But I have a very similar image, so the image is the same, it's just I'm using LDA instead of SVM for my training. So if I update my model, okay, so something pretty neat happens here. If I can type in time. So it actually, it's going to spin up a new, sorry, it's hard to see with the wrapping, but it spun up a new job because now I have a new type of model that I need to train, and my results weren't in sync with that. My version model wasn't in sync with that. So Pachyderm automatically updated my model. Then as soon as that model was retrained, Pachyderm knew that there was a new version model. So it updated my inference as a result as well. So the data here updated, and then Pachyderm said, oh, now the data here is updated, I need to rerun this. Yeah?
You have a cluster name, not cluster, a container named inference and output named inference. Where do we see the two separate entities in your Pachyderm version?
Yeah, so the two separate entities are like, so the question was, how do we distinguish between the different entities like inference and inference? So there's always, so these are pipelines and repos. So each pipeline has a corresponding repo of the same name. So that's by convention. But you can definitely, like, here if I list pipeline, oops, I can see that I have 2 of those running and their names, and I can also see their corresponding, repos if I list the repo. Now, here's the kind of like secret sauce, I guess. Not that it's secret, it's open source. But if I look, remember I've kind of run a few different jobs here. And now I get into a situation where I'm like, oh, well, what model created what inferences? I've changed my model, right? So I can go here and say, well, this inference that got created, let me inspect that one. So if I inspect that specific commit, this kind of comes back to the state of the pipeline at a certain point. This will tell me that this was the exact state of my training data that trained this exact model, wherever it is, this exact model. And that model took in these exact attributes to produce that exact inference. And so if I wanted to see what model that was, I could say, you know, get that one. And it turns out that was my LDA model. That was just a little bit of metadata that I output with it. Whereas if I look at the other one, remember all of this version, or all of this data is versioned, right? So I can go back and see what my model was at a previous time. So if I go back to, let's say, this inference, and I inspect that commit, then you can see there was a different model, right? And if I look at what that model was, that was my SVM model, right? So I have the complete tracking over that. I could also get the training data that was used in each case if I updated that. And this is kind of how you can track things through. You can either track them backwards, kind of like I did, or you can like go to a specific piece of data and say, what were all the other pieces of data downstream that were affected by this particular piece of data?
What about the Python scripts themselves? I didn't see that in the mix. You could modify your training script or your inference engine.
Yeah, definitely. So the question was around what about the scripts themselves? So here we are under the hood. At least you should be versioning your Docker containers, and we provide that kind of what was mentioned before, this tagging for the containers. And then a layer below that, you should still be versioning your code in GitHub. That kind of like still goes along with this. But if you wanted to know exactly what was run, like I can inspect the pipeline, let's say inference, and see exactly what my transform was, how many times it's run, all of that good stuff. And I should say too that I'm doing everything on the command line here, but like 2 weeks ago we released the first version of a UI. So it's still a little bit rough, but that's also open. And it's like Gabriel, who's working on it, is doing an amazing job. It's like progressing very fast. So you can also spin up with this and see like a connected DAG of everything that's run and what files you have and what commits have been made and things as they change and that sort of thing. Yeah.
You said you were able to go back and look at each one. Is there like some automated process to be able to do that, or do you have to use your shell commands to be able to get those files?
So right now, I've demonstrated with the shell, you can definitely programmatically do it with the Python client. But again, like the other way right now would be like with this UI that's coming out, and that will allow you to very quickly like click through and see what has changed where. Yeah.
Can you bring up your pipeline picture again?
Yeah, sure. So now I guess we're here.
From what I get, one of the cool things is you could do your training, your model, and your model output, and do your inference or whatever, just like you normally did. But if you change something in your attributes file, only inference will run, not the entire thing.
Yes. Yeah, correct. So remember that like Pachyderm is, so the question was like around what will run if you change certain pieces. So Pachyderm is keeping all of these, it's like declarative. Pachyderm is keeping all of this in sync. If I change this here, Pachyderm knows, like, this is all already up to sync. None of this has changed up here. I only need to rerun my inference to create new results. Similar, like, if you change your training here, it would rerun kind of all of this. So it's aware of what needs to be run. Yeah. Yeah.
All right. So I have a little bit simpler model that doesn't have the creating the model or anything, but are you able to accommodate different models of flow and things like that?
Yeah, definitely. So the question was, if you have different types of workflows or different models, like how does that fit in? So that's actually a perfect segue. So, and also related to one of the questions from earlier, we make no opinion about what you run here or the structure of your pipeline, just that you're running things in containers. Those are connected to version data. So, and remember, it's all language and framework agnostic. So here's our model, right? Now, like here, I want to run another thing, like you said, that takes in these two things, and with R, it creates some plots, right? So I can do that. And then if I want to do some like pre-processing of my data in Julia, I just take in that and do that for my training. And if for some reason I want to do some like pre-processing with a bash command here, I can do that. Like this could be TensorFlow or it could be a bash command, right? We really don't care. And then as things scale, you're totally free to scale up and down these workers individually as you see fit. Yeah. Yeah.
So is there a list view of, say, I have different models, just the diffs of the different models, and also the associated results that can easily gleaned over?
Yeah. Yeah, so the question was, is there a way to kind of have this like diff view of your different models or your files or that sort of thing? So there's kind of two answers to this. The first one is sort of no, and for a good reason, because in certain Git-like semantics pull through here, like committing and repos and branches, but certain things don't, particularly like merging and diffs, because if you're thinking about merging like petabytes of data, no human can resolve those merge conflicts, right? So that doesn't like really carry through. Now, with that being said, like if you wanted to like process based on diffs between like two different commits of a repo, that's something that you can definitely do. We're working on a little bit easier way to facilitate that now. So like I showed the different ways to put in your input. There's going to be another one that's like, I don't know what it's going to be. They're working on it. It's like diff or something where you can actually build up different commits of your data and process between the different states of them. So that's definitely coming. As far as like UI or clearly seeing that, not really at the moment. Yeah.
Say your pipeline creates thousands of plots. And you don't want to do get file, and I'm sure you can do it recursively, but can you do a repo dump to local, or can you mount the repo?
Yeah, so the question was if you had like a bunch of files and you want to get them all, like, is there a simpler way to do that rather than get file? So you can, like you said, you can do it recursively. You can also do it via the clients, so like programmatically you can get all the files, right? Or you can get like a directory and that sort of thing. We also provide, like, for development purposes, like a way to mount the distributed file system locally. So you could actually browse it, like mount the distributed remote file system locally, explore it, pull things in, and that sort of thing. It's not really good to use in like for production purposes because it like sometimes craps out. But it's definitely useful for that sort of exploration. Yeah. Other questions? Yeah.
Now, aside from the workflow part, the versioning part, I could imagine easily using just pure Git and persist and version my data and model and code in the same commit, and I would get the same thing, right?
So the question was like, why wouldn't we use just pure Git and version our data and our code and everything together? So I would say like two pieces. So the first piece is like if you're using GitHub, for example, you're not going to be able to store and version large data sets. It's just not possible, and nor is it space efficient, because actually under the hood, Git isn't space efficient with making copies and that sort of thing of this size of data. Pachyderm uses its own logic under the hood to be space efficient. So that's the first case. The second piece is like you can version everything together, and you'll see a lot of solutions these days where like there's project templates or there's like things that version all of your code and data together, but it doesn't really solve this reproducibility problem, right? Because I, as your colleague, could clone your repo and put things together totally differently and produce different results, right? So it, of course, is aided by documentation and all of that, but it doesn't like rigorously define how things were run. And also, like, for example, like if you're running things in production and you commit corrupt data or something, it doesn't give you a mechanism to tracking back exactly what commit was corrupt or reverting or overriding bad data or seeing exactly what produced what. So I think we have time for a couple more questions. I'll just put up this slide. So all of this code and the pipelines are online. Check out the Pachyderm docs. You can spin this up locally in like 10 minutes. It works. We have a public Slack channel that you can join to ask questions and that sort of thing. This is me. And, you know, we're open source community, so reach out anytime with questions and everything. And I don't know if we have time for more questions or what's up.
I just wanted to take the opportunity to at least thank Daniel first. For making the drive up here, for having the courage to live code. Right, that's always a tricky thing. And yeah, we have a little bit of time for questions. So,
what if somebody wants to contribute?
So if the question was, I'll get you here in a second. So the question was if somebody wants to contribute. So you can go to our docs here. Also on our website, pachyderm.io, it links to our GitHub. It's just pachyderm/pachyderm. And there's like a little blurb on there about contributing. All you have to do is like sign the, contributor agreement or whatever. It's all Apache too. And as soon as you can do that, you can submit pull requests and merge them and everything. So yeah, appreciate that. And if anybody wants to work on the Python client too, there's definitely things to do there. So yeah, question.
So in science, reproducibility has been an issue for a while, and there are a number of similar projects that do similar things. For example, Galaxy, or what we use in bioinformatics is called Lonnie pipeline. I'm not sure if you've seen it or heard of it ever before. Yeah. So that thing is very similar. And I'm trying to see like what's the advantages of your software package, because like I think it's very conceptually similar. And then again, because you're coming up with GUI and all that, so you can have your everything as a module, and then you can start building like nested pipelines where your pipeline becomes a module of other pipelines, and you can do like Lonnie allows you to do, for example, you run your Arbor pipeline, then you have like an if statement and conditional. Then you run either one branch or another branch, and they're like super nested, 5 levels underneath. And then, of course, if you do it properly, it gives you like data provenance, and you can go back, and then that automatically manages like how many workers you need. And you didn't mention, but
maybe let's let him answer the what is the advantage part.
Yeah. So like generally, and again, the question was kind of like there's a lot of other pipelining and in some cases versioning sort of systems out there. I would say like in industry, there's like outside of science, there's things like Luigi and Airflow, and then there's like projects like Infiny and the DAT project that do like data versioning. Then in science, like you were saying, I think there's Arvados and I know that there's SciPipe and like the one you mentioned, I forget the exact name. There's a bunch of these kind of workflows, especially in bioinformatics. The main things that I think like I've seen differentiating, and each project kind of has a different flavor, but I think this project, one of the things that it's really focused on, and I think one of the distinguishing features is this ecosystem of tools that it's built on. So being Dockerized, not that there are not other Dockerized ones out there, it's language and framework agnostic, which many are not. So there's a couple out there that are Dockerized. But then on top of that, being able to ride on Kubernetes provides a really, really high level of scalability and like availability and just general maintenance for your entire cluster, especially in large collaborative environments. I mean, this is really like Kubernetes is built for Google scale, planet scale, self-healing, scheduled workflows. So I think like taking advantage of those APIs provides a lot of power in this sort of environment and being kind of that data layer on top of Kubernetes. Other ones like Airflow and Luigi, they're kind of tied to specific languages in some way, or lack this like strict data versioning and provenance piece. And other projects that actually version data kind of lack the pipelining piece, whereas this is kind of all unified. Yeah.
I have a question.
Yeah.
Sorry. So the question I have is like when you have lots of data, a lot of time you transfer data to run a particular script. How does pack control take care of it? Does it like in the pipeline? Does it host the data with your model scripts, or do you transfer it to a different container?
So the question was kind of basically getting at where the data lives and where kind of how it's shimmed in. So behind all of this, so we write on Kubernetes for the one piece. The data piece is actually backed by any object store. So that could be S3 or GCS, or it could be like if you're on-prem, like Minio, Ceph, Swift, any of those. So we definitely lack the like strict data locality of like Hadoop-like systems. Of course, we have a lot of like smart caching to mitigate that. But at the end of the day, you know, we're likely not going to compete on Terrasort, nor do we want to. But the really kind of like different processing paradigm that we have is this incrementality. Like in those sorts of systems, if you've already processed 1 million images and you add one more to your set, we kind of automatically handle that incremental processing, which is a huge savings as opposed to like rerunning things manually without an awareness of what data has changed. Yeah.
So we'll have that be the last question, but we encourage people to come up and talk to Daniel, as well as to mingle a little bit longer. We have a space for maybe the next 15 minutes or so, but we also want to give people an opportunity to get out because it is getting late. So let's thank our speaker again, Daniel.
Thank you, guys.